Okay, so recording is starting, guys. So we're looking at binomial expansion, guys. Now, you are very familiar with this already. We've done binomial expansions. We've done binomials to the first power, binomials to the second power, binomials to the third power. Now we're looking at the binomials to higher powers, okay? So guys, when we were, let's say, in pre-algebra or something like this, we had a binomial such as x plus a to the first power, that would just equal to x plus a. But then we got to maybe algebra 1, where we got x plus a to the first power, to the second power. We had to expand this. How did we expand it? There's a formula for it. Or you knew you had to write it out and multiply it by itself. So you ended up with x squared plus 2ax plus a squared. Does that make sense? And then when you moved on, and I didn't mean for a 3 there. When you move further on, guys, to let's say algebra 2, you encountered these problems right here, where you had a binomial cube. So for the binomial cube, all you did was to take the answer from the binomial squared, which was x plus a times x plus a, and multiply it by another x plus a. And then you would FOIL it out. Now, I'm gonna have to erase this, guys, so I can go ahead and continue. Okay, I'm gonna erase it, okay? Moving on. So when you expanded x plus a to the third power as an x plus a times x plus a times x plus a, there's a pattern for this one too, but one of the ways students would do it is to multiply the first two binomials together, which is x squared plus 2ax times, oh Shazam, I forgot the third term, okay, there we go, plus a squared, and then they took this and multiplied it by x plus a. And of course, you would just go ahead and FOIL, multiply the x over every single term over here. That would give you x cubed plus 2ax squared plus a squared x. And then you take the a and multiply it by every term here. Okay, so this would give you ax squared plus 3ax squared, no, I'm sorry, 2a squared x, and then plus a cube. When you add all this up, this would give you the answer for x plus a to the third power. So x cubed plus 3ax squared plus 3a, oh Shazam, 3a squared, and then on x, and then plus a cube. All right, guys. I am not gonna move on to a, you know what, I could. Let me just mention something about this one. For this one right here, guys, if you have x plus a to the fourth power, which is x plus a multiplied by itself 4 times. Now think about this, guys, okay? That's an a. X plus a, and then x plus a. So think about this one. How would you do it? You'd multiply the first two, multiply the last two. So you would end up with x squared plus 2ax plus a squared. And then you multiply it by itself, okay? So that's how you would do it. But let's focus on this one right here. I need to make a point. All right, guys. So what are some of the things you notice? And I need you guys to speak for this one, okay? What are some of the things you notice about this problem right here when it comes to finding the expansion of x plus a to the third power? Anything you notice about the terms? Nothing? Oh.
The first and the last term are all to the third power.
Very good. The first, ooh, Shazam. Let's try that one more time. Okay, that's a good observation, Lee. Very good observation. Okay, guys, so the power of the first term and the power of the last term, they're exactly the same thing. Now, I'm asking you to look at the problem and make these observations, guys, because it's going to help you with the binomial extensions, okay? Anything else, guys?
And then the second term and then the third term, they're both being multiplied by 3. And then, well, one is to the second power for x, the other one is to the number, the constant.
Okay, very good. All right, so you said a whole lot. You're saying both the second term, let me use my pointer here, both the second term and the third term, okay, they are exactly the same coefficients, okay? And furthermore, what I noticed is that the power on this x right here on the second term is 2, and the power on the third term is 1. Now, let me do this, and I want you guys to tell me what you're observing. The power on A over here is 1. The power on A over here is 2, and the power on X is 1. So now what do you notice? Anything, guys? All right. So let me tell you. When you add the powers, it equals to 3. Very good. What is that called, Sarah? Anybody remember? What is that called? When you add the powers, it's equal to 3. So what would we call the 3 in relation to the term? Anybody? Okay. So let me go ahead and write that down for you guys. So this means that every term has a degree equal to the power, a degree of 3. The degree is exactly the same for every single term. Now, additionally, guys, when we started with this binomial, it was a third degree binomial. How many terms do we have in this problem?
4.
How many terms? We have 4. So what happened is this. We had a binomial to the third power, and I'm going to refer to the power as n, but the number of terms is equal to 4. So when we generalize this, we could say this: the number of terms is equal to the power plus 1. Now, if we call the power n, so then the formula would be n plus 1. So this is another one. When you're expanding the binomials, guys, the number of terms is always going to be the degree of the binomial plus 1. The power on that binomial plus 1. So I just mentioned 2 things to you. First and foremost, okay, the degree of each term in that binomial expansion is always equivalent to the power on that binomial. Number 2, the number of terms the binomial expansion will have is the power on the binomial plus 1. Or in this case, I wrote it down as n plus 1. Okay, now let's see what else you guys notice on this binomial expansion here. Let me erase some of this. Now, it may take you guys some time to recognize some of these additional components. So let me give you some of the additional components and then we'll move on. All right, guys. So next, what I want you to notice is that the degree of the first term is 3. The power on x is 3. The power on the next x is 2. The power on the next term is 1. So in other words, the powers on the x's are going forward in descending order of powers. However, let's look at the powers on the second term. And the second term was a. Now, we have 1 over here, okay? Right here, that's 1. Now remember, we said the degree of each term must add up to the power on the binomial. So the power on the a starts here with a 1, because when you add 1 and 2 together, you must get 3. The power here is 2, and the power here is 3. So what do you notice is happening with the powers on the second term? They're increasing from left to right. By the way, it starts at 0, guys. If you have a raised to the 0 power, anything raised to 0 power is 1. So that first term has a power of a, except it's 0 and it's equivalent to 1. Same thing with the last term. You don't see an x here. Why? Because x to the 0 power is equal to 1. All right? So what did I just mention here? What I mentioned was that the powers on the first term of the binomial go forward in descending order, okay? And the powers on the second term of the binomial goes forward in increasing order until you get to the power of the binomial. And we'll be working on that, okay? Now, next, guys, let's chat about this next part before we go ahead and move on. At the beginning of this chapter, we saw the factorial symbol. I asked you to calculate 5 factorial. So when you see the factorial symbol, it just means that you're taking a number and multiplying it by all of its preceding values, okay? That's how you get the factorial. But then, of course, you guys have that on your calculator already, so you don't have to worry about it. Now, this next part right here is going to help us to determine the coefficients of each term in a binomial expansion. All right, guys. Now, when we talk about this, this is the symbol we're going to use, okay? That's the symbol we're going to use. And when we read this, we read it as n taken j at a time. Now, earlier, I told you guys to find this symbol on your calculator, NCR. By the way, guys, this and that are the exact same thing. The combination of n items taken r at a time and taken j at a time is the same thing, all right? Any questions, guys? So if n and j are integers, all right? They're integers as in their whole number is negative, positive, 0, okay? And j is greater than or equal to 0, but less than or equal to n, then this means that, ooh, Shazam, I'm running out of room, so I need to get to the next page. By the way, guys, just so you know, n right here represents the power on the binomial, and j represents the term. Which term are we talking about, okay? Once again, n represents the power on the binomial, and then j represents the term. All right, guys. So I am going to turn this over so we can go ahead and continue. All right, so guys, that n choose j is a formula, and it stands for n factorial over n minus j factorial times j factorial, okay? By the way, this is the same thing as NCR. NCR means the exact same thing. N factorial over n minus r factorial times r factorial. This is primarily in stats, and let me write this down for you guys. This has to do with the combination of items, all right? The combination of items. All right, now let us practice, guys. So let's say you have something like this, and I'm just gonna give you an easy one. Okay, let's do this one right here. 8 choose 6, okay? And you need to simplify this. This stands for 8 factorial over 8 minus 6 factorial times 6 factorial. Now, if you recall last time when we do a factorial, this would represent 8, you're multiplying each of its successive numbers, okay, by that number. So 8 times 7 times 6 times, oh shoot, I forgot to do an intermediate step. Let me go back a little bit. because I should have subtracted here. Okay, so let me go ahead and do my little subtraction here. Okay, so when I subtract, I get 8 factorial over 2 factorial times 6 factorial. Now we can simplify it. 8 factorial in the numerator means 8 times 7 times 6. I'm pausing here because I don't need to go further, and I'm going to show you guys why. Because in the denominator, we have a 2 factorial and we have a 6 factorial. This is why I stopped. Since I have a 6 factorial in the numerator, 6 factorial in the denominator, I'm going to cancel them out. So I'm left with 8 times 7 over 2 times 1. 2 goes into 8 4 times, and 4 times 7 is going to give me 28. So guys, this would be the answer, 28. All right. So now, because we are practicing, I need you guys to grab your calculators, and we're going to type this into the calculator. Okay? This is how you type it into the calculator. On your calculator, you need to be on your computation screen where you do all your computations, okay? So I did 8, choose 6. So you're going to type it on the calculator, guys. 8. So on the graphing calculators, you need to go and find your NCR, okay, which is under math, and then you move over to PRB as in probability, and you guys said it was option 3, so hit that, and the NCR will come up, and then you type in the 6 and hit enter. Okay. Now you guys tell me if you got your answer of 28. Give me a thumbs up if you got your answer of 28. Wait. Okay, Presley, I'm waiting. Sarah got it. Laura didn't get it. Laura, do you have a graphing calculator? Yes, you do. Okay. Okay, I think I saw one person. You did the 8, then you had to do the NCR again. No, Presley. You do 8, go to math, move over to PRB, and then type in the number 3 or move down to number 3, hit enter. It brings you back to the main screen, and then you type in the 6 after it, okay? So basically that first number represents N, and the second number represents R, and you should have gotten your answer of 28.
Miss Sarah, so when you cancel out the 6 factorial, so when you cancel that means that any numbers after the 6 is gone, correct?
Yes, absolutely. That's what 6 factorial means. Yep. All right. All right, perfect. Okay, guys. So here are some basic rules of the factorial. If you have n, choose 0, guys. This one is going to equal to 1. Okay, basic rules of factorial. N, choose 1 is going to simplify to just n. If you have n, choose n, this one is going to simplify to, guess what? What does it simplify to? Anybody? No. There we go. 1. Very good. Awesome. So now, guys, you know how to plug these into your calculator. We're going to go ahead and move on to the next part of this. All right. So we are going to be using these to find the coefficients. Another way for you to find the coefficients, and I'm going to give you the short end of it, is to use Pascal's triangle, which is named after the mathematician, by the way, French mathematician, Blaise Pascal, who is credited with finding a whole lot of stuff in mathematics. He discovered a whole lot. It's just like E is also referred to as Euler's number. Euler was like the father of mathematics, guys. There's even a textbook, I think it was called Euler's theorems or something like that, that I used for one of my classes. Is Pascal the pressure guy? I think so. Don't quote me on that, but I know what you're talking about. That's a good question, Gabby. I'm not quite sure, but I think so, okay? Just don't quote me. So anyways, going back to this, guys, just like E, 2.718 is Euler's number because he's the guy who discovered a whole lot about these mathematical theories, okay? So anyways, let me go ahead and carry on. With Pascal's triangle, guys, this is another way to find the coefficients. And I'm going to tell you why we don't use it that frequently, why we have to use the combination, or in this case, the factorials, okay? Where we use this to find the coefficients of the terms of a binomial, coefficient of the terms of a binomial expansion. Now, guys, listen, again, I'm taking the shortcut. There's more to this, but I want to make sure I expose you today. This is wrong, expansion. Okay, so guys, here it is. At the top, it's a triangle, by the way. How many of you have seen Pascal's triangle before? Give me a thumbs up if you've seen Pascal's triangle. Anybody? Ooh, ooh, ooh. Okay, nobody. In the days, way back in the days, guys, when I first started teaching, I used to teach Algebra 2, and that was part of the curriculum. Now they don't include that in the curriculum. All right, so guys, here we go. At the top of Pascal's triangle, we have 1. This 1 represents the coefficient of a binomial to the 0 power, because anything raised to the 0 power is equal to 1. On the second level of Pascal's triangle, we have 1, 1. This represents x plus a to the first power, as in the coefficient of each term is 1. Now, this is where things start to change. On the next level, which is the third row, we have 1, 2, 1. You notice the outside are still 1s. This would represent x plus a to the second power, which we just expanded, guys, earlier, and we had gotten x squared plus 2ax plus a squared. So basically, the coefficient of the first term is 1. Coefficient of the second term is 2. Coefficient of the third term is 1. Now, this is really where it starts making a whole lot of sense, and it starts coming together, okay? And I pulled it all together for you guys, okay? So here's the next one. 1, 3, 3, 1. You notice you still have the 1s on the outside. Now we're on the fourth row. Remember, if you take a binomial to the fourth power, to the third power, and you expand it, you're going to get 4 terms. So the coefficient of the x cube will be 1. The coefficient, excuse me, the coefficient of the second term will be 3, but then the terms are going to be ax squared, okay? The coefficient of the third term will also be 3, and the powers will be a squared times x, and then the last term will be a to the third, and its coefficient will be 1. What's your question again, Natalie? One more time. What is a coefficient? Is that your question? Go ahead, you can speak up, Natalie. I can hear you. Just turn on your mic.
I didn't know what the COEF stood for.
Oh, coefficient. You're good now? Or do you want me to explain it?
Yeah.
Okay. Is the 7 on the x plus a supposed to be a 1? Is the 7, that's supposed to be a 2, Gabby. That's a 2. Okay. All right, guys. So now I want you to look at the triangle. Let's see, Pascal's triangle, if you guys can come up with the terms on the next line. Oh, Shazam. Him. Okay, Gabby, I'm wrong. You're right, that's a 1, Sarah. Shazam, shame on me. Okay, there we go. All right, because the second one is a 2, you're absolutely right. Okay, you know what it is? Sometimes, guys, when this stuff happens to me like that, it's because I get too excited and I get discombobulated. Anyways, let's keep going. So, let's see. What's the first number here on the 5th line of Pascal's triangle, guys? Okay, how about you guys give me all the numbers? Give me all the numbers in the row. Give me all the numbers. Okay, okay. Josh says 14441. Paige says 14641. Anybody else? Presley's a little lost. Okay, anybody else? Okay, Sarah also says 1441. Here it is, guys. 1, 4, 6, 4, 1. All right, so what just happened, guys? How do we get the 4? I need you guys to speak up for this one. How do we get the 4? Come on, guys.
3 plus 1.
3 plus 1. You add 1 plus 3 from the previous term. How do we get the 6? Same thing, 3 plus 3. How do we get this 4 over here? 3 plus 1. Okay, so how did we get the 3 over here? We added 2 and 1. How did we get the 3 over here? We added 1 and 2 together. So then the next line would be, what's the next line? Yes, the power would be 4, Sarah. So what's the next line, guys? Excuse me. What's the next one? Come on, Presley, you can do this. 1, 5, 10, 10. You missed 1. Okay, Paige got it. 1, 5, 10, 10, 5, and 1. All right. So guys, what I want you to notice is that there is a pattern. There's a pattern. Okay. Now, here's why this is not very efficient. Okay. So this one right here, let me see here. Let's use a different color. Okay. So this line right here represents a binomial to the 4th power. This line right here represents a binomial to the 5th power. Now, guys, here's the problem. What if they would ask you to expand a binomial to the 12th power? What would you do to find these coefficients? Would you have to sit there all day long and draw out Pascal's triangle until you get to that line where the second number is 12? No. That's not very efficient. And that is why we use the factorials, AKA the combination, in order to find the coefficients of these. All right. So now, guys, finally, I'm ready to start expanding some of these binomials. So, guys, I am going to go through this very slowly for you guys to understand what's going on. We're going to expand an easy one first, okay? X plus 3 to the 5th power. All right, let me see if I could turn this sideways. How does this look on your screen? Does it look okay?
Yeah.
Can you guys see all of it? I love technology, Shazam. Okay. And I'm writing it sideways, guys, because I want you to be able to see everything. Okay, so guys, here we go. Remember, we're going to write out the terms. Well, first and foremost, guys, how many terms will this binomial expansion have? How many terms will it have? 6 terms, okay? Now, we're gonna start off by writing the first term in the binomial, that's the x, to the 5th power. And we're gonna talk about the coefficient in a little bit, okay? Give me a moment for the coefficient. We'll come back to the coefficient. Next term is going to have x to the 4th, but the 3 will be raised to the 1st power. Are you guys okay with that? Remember, every term, guys, every single term must have a degree of 5. I'm going to put the 1 here so you guys can see it. Okay, the next term is going to be x to the 3rd and then 3 squared. Remember, the degree of each term must add up to the degree of the binomial. The next term, which would be the 4th term, will consist of x squared. You know what? Let me put this on here so I can remind you guys, you got to go back in and plug in those coefficients. because right now I'm not doing this with any coefficients, okay? So, so now guys, the next term, oh, I forgot my 3. This was going to be 3 to the 3rd. And then the next term, that was the 4th term, so we're moving on to the 5th term, will be x, and then 3 to the 4th. And then the last term will represent 3 to the 5th. Now remember, we have coefficients here. I forgot to put the line here, meaning we have a coefficient. Right here as well, we have a coefficient. All right, everybody. Now, if we were using Pascal's triangle to do this, we would simply go ahead and plug in those coefficients. What was the coefficients? It was 1, 5, 10, 10, 5, and 1. And of course, all of this is multiplication. So now, guys, we're going to finish this out and write the binomial expansion. So the first term right here, 1x to the 5th, just becomes x to the 5th. The next term, we have a 5 here, which we're multiplying by 3. So we get 15x to the 4th. The third term, we have 10 times 3 squared. 3 squared is 9. 9 times 10 would be 90x to the 3rd. Now, the fourth term is 10 times 3 to the 3rd. 3 to the 3rd is 27. 27 times 10 is 270. X to the 2nd. I want you to notice how the powers of x are moving forward in descending order of powers. Now next, guys, we're going to multiply the coefficient of 5 by 3 to the 4th. 3 to the 4th is 81. 81 times 5. 5 times it is 4. Oh, that's 405. And then x. And then the last term is 3 to the 5th power. 3 to the 5th power, 3 times 8 is 24. That's going to be 243. So there's the binomial expansion using Pascal's. Yes, guys, I'm pausing. That was your first binomial expansion, guys. Some of you may not have gotten it. Does 405 have an x? Yes, there's an x next to it. Yep. You can't see that part? The screen cuts off the end. Ooh. Let me see if I turn it, what happens. Ooh. Okay. Well, that's interesting. Very interesting. Okay, so it allows me to write beyond the screen. Okay, so Leslie, the last term represents the 3 to the 5th power, and 3 to the 5th power is 243. So there's a 243 at the end representing the last term. That's weird. Your camera is covering the rest, but now it works. Okay. I can move the camera. How so, Jasmine? We can move the video over. Click the top. And then on my display. Okay. Click the top and drag it. We can now see it. Okay. All right. Just click and drag the video. Click and drag the video. Okay.
Oh, I can't see my mouse. I can't.
No. I think I'm gonna have to practice that one in another day. Okay. I think I had my fill of practicing today with technology. Okay. But thank you. I will try that. I did not know I could do that. Just click and drag the video. Okay, I will try it, definitely. Okay, guys, so ask me questions. Anything? Okay, if you don't know what questions to ask, that's okay. I'm gonna do a second one. Now for the second one, oh, you mean the students can move the camera. Oh, Jasmine. Okay, let's move on. I'm gonna move on. Okay, I'm gonna do an, huh? Okay, I'm gonna do another one, guys. Okay, but this time I am going to use the factorials to come up with the binomials, okay? I mean, to come up with coefficients of the binomials.
Yay!
Yes, go ahead. Who just said wait? Someone just said wait. Yes, Gabby, even though it's not efficient, it works every time. Yes, because you see those numbers right there. Absolutely. So guys, here comes another one. And I'm also going to do 1 to the 5th power because I want you to actually see where the coefficients are coming from. So this time we're going to expand x minus 2 to the 5th power. Okay. So guys, here comes the coefficients. Okay. Now for the coefficients, okay, it's going to be in this form right here. And choose something. N is always going to be the power of the binomial. Always. And then J right here will represent, okay, now be careful with this, the power of the second term in the binomial. Okay, now to complicate things, so this problem, I have a negative in there, guys. Because there's a negative, the terms are going to alternate from positive to negative, okay? Why? Because if you have a negative raised to an odd power, this will be a negative. However, if you have a negative raised to an even power like 4, this will be a positive. So the signs are going to alternate positive, negative. All right, guys. So I'm ready to go. If you are ready to go, you're good? All right. Is the binomial to the 3rd or to the 5th? To the 5th power. All right. Anybody else? Wait. I'm waiting, Jasmine. All right, guys. So here we go. I'm erasing all of this so we can get started with it. This is used to be one of my favorite parts of teaching math. Or is it still is? No, I'm gonna tell you why it's not, guys. Because I have the consumer chapters in some of my math classes, and you know how much I love talking about money. All right, guys. So here we go. The first term is going to be 5. Choose 0. That's the coefficient, okay? And then the power on the x is going to be 5. That's the first term. All right, now we're gonna move on to the second term. It's gonna be 5, choose 1. And the power on the x is going to be the 4th power, but the power on the negative 2 is going to be 1. How you guys doing? Okay, next. The next one is going to be 5, choose 2. Ooh, Shazam. Okay, guys, technical difficulty here. You know what? Let me do it sideways. Ooh. Which reminds me, if I keep writing, because guys, I'm at the end of my screen right here. Are you guys able to move your camera to see the rest of it, or do I need to go to the second line? You don't know? Okay, because I'm at the end.
You'd have to go to the second line because that's where our screen cuts off.
Okay.
If you had it longer,
So
I think
you can't move your camera, Paige?
Huh?
You can't move your camera?
I can, but it's not blocking anything where you're writing.
Okay.
Because I just have the single column. It's only when you turn it horizontally, my camera blocks it and I have to move.
So when I turn it horizontally, you can't move your camera?
You can still, like, I just have to move it out the way to see everything. But if you
Okay.
hold it this way, it's
All right.
not in any way.
How's it going right now?
It's good you have room.
All right. So then I guess I'm gonna go to the next line. I'm confused on this. I don't understand the format or how you're writing equation out. Okay, Wesley, this right here represents the coefficients. When we're writing out the term, first and foremost, Wesley, this problem is just like the previous one. It's still to the 5th power. Of course, the first thing you have to ask yourself is, how many terms, number of terms in this binomial expansion? How do we calculate how many terms? We take the power, which is n, and we add 1 to it. So in this case, the power is 5, we add 1 to it, that gives us 6. We're going to end up with 6. When you start writing the terms out, you're going to go forward in descending order of powers of the x's, and you're going to go forward in increasing order of powers of the -2, starting with -2 to the 0, then -2 to the 1st power, -2 to the 2nd power, and so forth and so on. Additionally, as you're writing out the terms, keep in mind the degree of each term must add up to the power on the binomial. So for example, the degree on the first term is 5. That's the degree of the binomial. On the second term, you have a 4 plus 1, which still gives you 5, okay? Now, the only thing I added here in comparison to the last problem is the coefficient. When you plug in the coefficients, which is what's underlined over here, Presley, you're going to do n choose, n is the power of the binomial, choose the power, and I'm going to use J for that, the power on the second term of the binomial. So in this case, the power on that 2. When you start out with the first term, this is always going to be 5, Presley. You're always going to have a 5 on top. However, the bottom is going to change to accommodate the power of the second term in the binomial. All right? So now, guys, I am already on the 3rd term. I am going to move on to the 4th term. For the 4th term, Presley, it's still going to be 5, but right now I'm on the 5th term. It's going to be choose 3. 0, 1, 2, 3 is the next one, okay? And then this is going to be x to the 2nd, because I'm going in descending order of powers. And then to make up to 5, to get it to 5, I'm going to make sure the power on the -2 is 3. Why? Because if I were to, let me use a different color. If I take 2 and 3 and add them up together, that has to give me the power of the binomial. Why is the 2 negative? That was just the problem, Josh. Come on. Josh, are you still sleepy? Okay. All right. I am going to move on, guys. Next term is going to be 5, choose 4, and x times -2 to the 4th power. The next term, I am going to get to the next line because I think some of you might not be able to see it. It's going to be 5, choose 5. Okay, let me see. 1, 2, 3, 4, 5. This is the last term, actually. And now, guys, I ran out of powers of x, so I'm just going to have -2 to the 5th power. All right, I'm pausing here just in case you guys have some little questions. Anybody? No? All right, so now we're going to grab our calculators and start doing this. But because we just talked about Pascal's triangle, you guys already remember what they are, you can go ahead and use that fact, or you can actually start plugging these into your calculator. For example, this one right here, guys, 5, choose 4. On your calculator, you would do 5, your NCR button, and type in 4, and that should give you an answer of 5. Okay, and as you do these combinations more frequently, you will notice some patterns and you don't even have to put it on your calculator. You can just automatically figure it out. All right. So what is the answer to this problem? Let's look, guys. The first term will end up being x to the 5th. The second term is going to be -10. Ooh, Shazam. I put a plus there. Now, -10. You know what? Let me use a different color. Why is it -10? I'm multiplying -2 times the coefficient. 5 choose 1 is 5. -2 times 5, that's -10. And an x to the 4th. Notice it's 5, 4. So the next term is going to be 3. All right, guys. So now for the third term, we're going to do 5 choose 2. And then we're going to multiply it by the -2 to the 4th. And this is going to be an addition. 5 choose 2 is going to be 10. 10 times 4 is going to give you 20x to the 3rd. All right, one more time, guys. I do 5 choose 2. 5 choose 2 is going to simplify to 10. On your calculators, you can plug it in. Then you've got a -2 squared, which you're multiplying. So that gives you a +4. Then I take the coefficient and I multiply it by the 4. And that's how I'm getting, oh, Shazam. That's supposed to be 40. All right, there we are. Let me rectify this one right here. That's 40. All right. So now, guys, moving on to the next one. Be careful. It's not the same thing as this one, okay? The next one is going to be a minus, because remember the signs are alternating, positive, negative. That's the first thing. Next, we're going to do 5 choose 3. Can you guys see this? 5 choose 3, I'm writing on the side. Yes, no? Okay, all right. Okay, good. All right, guys. Okay, we're almost there. 5 choose 3, and then I have a -2 to the 3rd power. 5 choose 3 is going to come out to be 10. -2 to the 3rd power is -8. So when I multiply, I get 80. So this one's going to be 80x to the 2nd. All right, I am going to pause here. I'm on the 4th term. I want you guys to tell me what the 5th term is. What's the 5th term? Let me erase this. All right, so the 5th term, guys, consists of 5 choose 4 times -2 to the 4th power, which most of you have figured out. Laura, Lee, Gabrielle, and Paige. Oh, Paige, you forgot your X. Lee, you forgot your X. Okay, so it would be 80x. All right, and then last but not least, the last term. What's the last term? -32. All right, guys. So now you should start feeling a little bit more comfortable with this. Yay, I love those thumbs up. Keep them coming. Yes, yes. All right. So you mean if I were to, oh, everybody's giving me a thumbs up. That's awesome. That is awesome. So you mean if I were to go ahead and give you guys one right now, you guys could go ahead and expand it on your own? Okay, sounds like that. Okay, so guys, here comes your problem. Let me see here. Let me find a good one for you. And I'm going to give you some good time to work it out. Good amount of time. Oh, yeah. You know what? I'm not going to do a 5th power. I'm going to take it to the next. Should I take it to the next level up? Ooh. You know what? You guys are a pre-calculus class. You guys can do this. Shazam. Let me stop holding your hands. 2x plus 3. Raise the 6th power. All right, guys. Go for it. What was that? Who? What the heck? Who was that? Battery low. Okay, let me fix that. Take your time, guys. Slowly work out everything. Write out everything. We're almost done. I've got one more thing to discuss with you guys about finding specific terms. And then we'll be done. Oh, Sarah, did you hear about graduation? I kind of got the other, but now I don't understand how to do it on my own. Okay. Dun, 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 dun. The market just opened. I'm checking on my stocks, guys. Ooh. What the heck? What in the world? The 2 is throwing me off. Put it in parentheses. All right. So, let's go ahead and get started, guys. So 6, choose 0. 2x, I am enclosing it inside a set of parentheses for the first term because there's a 2 and there's an x you have to worry about. And that will be raised to the 6th power. The second term will be 6, choose 1. And then 2x to the 5th times 3. The third term, 6, choose 2. Guys, it's a pattern. Just follow through the pattern. When you're writing out the coefficients, the top number remains the same. It's only the bottom one that's changing. As you move forward, the bottom number is increasing. So it'll be 2x to the 4th, 3 to the 2nd. Remember, the powers must add up to the power on the binomial. The degree for each term must be equivalent to the power on the binomials. All right, next, 6, choose 3. And then 2x to the 3rd, 3 to the 3rd. Now I'm putting the 3 in parentheses, guys. It really doesn't have to be in parentheses, but this is habit forming because remember with the previous problem, there was a -2. So by inserting that -2 inside a set of parentheses, it makes a difference, especially when you go and plug it into the calculator, okay? But if you remember the fact that if you have a negative value there, the terms are going to alternate, you'll be fine. By the way, one quick question, guys. How many terms are going to be in this binomial expansion? How many terms will be in this binomial expansion? 7. Very good, Laura. Okay. All right, guys, so I'm going to continue. So the next one is going to be 6, choose 4. And it's going to be 2x to the 4th power and then 3 to the 2nd power. All right. And then we're going to do 6, choose 5, and it's going to be 2x. Ooh, Shazam, I did the wrong thing. Not 2x to the 4th in the previous one, guys. That's wrong. That's supposed to be 2x squared. And then this one is going to be 2x, and then 3. Ooh, Shazam, I made a lot of boo-boos on this part, guys. Right there. Fix that for me. That did not add up. See how you can go back and check yourself just like that? It needs to add up. Okay, so I know this one is going to be 3 to the 5th power because it must add up with the 1 to get you to 6. And then the last one, guys, is going to be 6, choose 6. And then I will not have an x. I will simply have a 3 to the 6th power. All right, so now we're ready to simplify each term. What number is next to the 6 over 2? 6 over 2. Oh, that's a 2. Remember, that's the first term. All right, guys, so now we're going to work out everything. Now, one of the things I would suggest you do, okay, here are some shortcuts. I'm going to show you. 6, choose 0 is 1. I would just get rid of it, not worry about simplifying it. 6, choose 6. That's also 1. I would get rid of those and not worry about it. Now, 6, choose 1 for the second term. That's just going to come out to be 6. So I wouldn't worry about that one at all. Okay? What I need to worry about is this one right here, this one right here, this one right here, and oh, this one right here is just going to come out to be 6 as well, guys. Okay? So I wouldn't worry about that one either. So find the shortcuts, guys. Find them. Okay. So the first term for this one is going to be 2x to the 6th power. Okay? As in 2 to the 6th power times x to the 6th. 2 to the 6th power times x to the 6th is going to give you 64x to the 6th power. I'm pausing here for those of you who may not be able to come up with that. Ask me questions, guys. Type your questions in the chat box, or you could just go ahead and ask me. Can you explain again? Okay, Presley, what do you want me to explain? Which part do you want me to explain? Because there's a whole lot here. You sure? All right, guys. Now, the second term, I'm ready to move on to the second term. Okay, so on your calculators, this is what you would plug in. You would do, on your calculator, 6 times 2 to the 5th times 3. Because 6 choose 1 simplifies to 6, and then you've got 2x to the 5th power, okay? So you do the 2 to the 5th power, and then multiply it by the 3 at the end. What number does that come out to, guys? Because that's 18 times 32. And that would be x to the 5th. Ooh, what in the world? Oh my God, I'm discovering things on here I never knew existed. Okay, now how do I get back? Oh, there we go. Shazam. Okay. All right. By the way, guys, my color just changed. That's okay. By the way, guys, you don't have to worry about the powers of x because they're moving in descending order of powers. Okay. Oh, all right, Lee. I see you. Okay. Thank you, Lee. All right, guys. So for the third term, okay, this is what you're going to do on the calculator. You got to do your factorial. So you're going to do 6, your NCR, unless you know what it is. Okay. And then 2. And once you get your answer, you're going to do times 2 to the 4th times 3 to the 2nd. And Lee just gave me the answer as 2160. I see you, Sarah. Paige just gave me the answer too. And that would be x to the 4th. Awesome. Next. For the 4th term, we're going to do, on the calculator, 6 NCR, and then 3. Now, we're going to multiply that, whatever the answer is, 2 to the 3rd times 3 to the 3rd. Okay, and some of these ladies are way ahead of me, so that's 4320. So 4320 times x to the 3rd. Okay, guys, we only have, let me see here, 7 more, no, not 7 more terms. There's a total of 7 terms. We only have 3 more terms to go. All right, so here comes the next one. We're going to do, rather than having to write it out, how about you guys do it? The 6 choose 4 times 2 squared times 3 to the 4th. And that one comes out to 4860. And then x to the 2nd. Now we get to the 6th term, which is 6 times 2 times 3 to the 5th. So that's going to be 2916 x, oh, just x. And then finally, 3 to the 6th power is 729. And there you go, guys. There you are. How you guys feeling? All right, guys. We got one more to go, one more thing to go. Tired. I know it, Josh. It is tiring. But this is exciting. This is a lot of fun to me. It's tiring, but a lot of fun. Okay. So guys, when we're expanding a binomial in the form of x plus a to some power, we can take this and generalize it into this little formula right here. We do n choose 0 times x to the n. Then we do n choose 1 times a times x to the n minus 1. Then we do n choose 2 times a squared times x to the n minus 2, and so forth and so on until we're done as an n choose n, okay, times your a to the f power. Does that make sense? Or no, you should do j power, okay? So guys, when we do these binomial expansions like that, it's tedious, but it's not difficult, okay? You can do this. It's not that difficult, okay? I put an N here. That should have been a J, all right? Now, guys, I am going to do one last thing, and then I'll be done with you today. And this one last thing is about finding a specific term of a binomial expansion. Finding a specific term of a binomial expansion. For example, a problem might ask you to find the 3rd term of x plus 2 to the 4th power. That's easy, but anyways, we'll do it. All right, guys. So for this one right here, here's how we're going to do it. Okay? I want you guys to think carefully. Now, every term must have a degree that is equivalent to the original power of the binomial. We're looking for the third term. So the question you have to ask yourself is, what will be the power of the x on the third term? So an easier way to do it, guys, is to actually count backwards. There's a general formula for it, but I want to explain it first. So an easy way to do it is to go ahead and count backwards. 4, that represents the first term. That's the power on the x. 4, and then 3, second term. 2, the third term, okay? So I've got 3 terms, but then the power on the x is going to be 2. So the power on the x, I wrote the wrong thing. The power on the x is going to be 2. Now, if the power on the x is 2, then that means that the power on the 2 will also have to be 2. Why is that? Because, guys, remember, when you add the powers, it must be equivalent to the power on the binomial. So if you add the power on the x, the power on the 2, that gives you 4, which is equivalent to the original power of the binomial. And now you need to worry about the coefficient. How do you find the coefficient? Well, remember, when you do the coefficient, it's going to be 4 choose the power on the second term. So 4 choose 2. What do you guys think? And then you work it out, guys. You work it out. Okay, 4 choose 2 is going to give you 6. And then 2 squared is 4. And then x squared. So the answer comes out to be 24x squared. And you can do that 4 choose 2 on your calculators. Does that make sense? Okay, so sounds to me that you guys want something harder. Okay, so here's one. Find the sixth term of x plus 2 to the 9th power. Okay, so to help you guys alone, and I'll give you the general formula in a little bit, okay? Count backwards, guys. We want to go to the 6th term. What we're keeping track of right here is the number of terms. What we say is the power of the x, the power on the first term. So if we're counting backwards, we're doing 9, 8, 7, 6, 5, 4. Okay, so we got the 6th term, but what's the power on the binomial? The power on the binomial is going to be 4. The power on the x, I'm sorry. The power on the x is going to be 4. And to make up for the power of the other term must have a power of 5, because when you add 4 and 5 together, it has to give you 9. Now, for the coefficient, it's going to be 9 choose 5. So somebody throw that on a calculator for me.
It's 4,032 x to the 4th power.
4,032 x to the 4th. All right, people. Oh, wait a minute. Whoa. I thought, okay. Paige is giving me 1,152. And you're telling me, Lee, 4,032.
Yeah.
There's a discrepancy, guys.
Wait, why is it's 9/5? Because
9, remember, is the power of the binomial. 5 is the power on the 2.
oh, okay, thank you.
I got 4,032 also. Thank you, Gabby. Thank you, Laura. Okay, very good. So now I want you guys to try one on your own. Let's see what you come up with. Ooh. All right, guys. So here's one. I want you to find, let me see, find the fifth term of 2y plus 3, the 10th power. Ooh, that's 10. How you guys doing? Did you guys get it? Oh, everybody dropped out on me. Shazam, what time is it? Oh, okay, it's getting late, guys. I'm gonna let you go very shortly, and then I'll give you the general term formula. I'm calculating it myself because I didn't do this one yet. You got 4,000. Wait a minute. Oh, okay. You guys are coming out with a whole bunch of different answers. Okay. Hold up a second. Let me go ahead and do this. Okay. Hold on, guys. I'm going to tell you what it is. I'm still doing it. Okay. Yeah. Okay, so here it is. It is nobody got this? Okay, Sarah got it. All right. You got the y to the 5th, Natalie, but the coefficient didn't add up. Oh, wait, never mind. I forgot the 2. Laura, so wouldn't it be the
Wait, I saw
6th
Sarah.
power? Okay, well, let's count it out. I forgot to multiply the 2. Okay, let's look. So we got 10, 9, 8, 7. Ooh, I'm
Six.
going to the 6th power. Why do I have the 5th power? Shazam. Okay.
I counted to make sure it's the 6th power, not the 5.
Ooh, I left out one of my terms. That's why. Okay. So scratch my answer. I'm going to go back and do it. Okay, guys? Scratch that one. Okay, so 10, 9, 8, 7, 6. So that's 5 terms right there, but the power is 6 on the first term. So when you write it out, it's going to be 10, okay? And you're going to have to choose 4, and the power on the y is going to be, what did I say again? 6, and then the power on the 3 is going to have to be 4 because you want it to add up to 10. All right, so let me try this again. 10 choose 4. Let me see what that one is going to come out to be. 10 choose 4 times 2 to the 6 times 3 to the 4th power. So my answer is 10,88640 y to the 6. All right. There we go.